along with his 3 friends, initiated a startup named ChargeMOD, which soon grabbed attention in electric vehicle field and gained sufficient momentum to gear up to the higher levels due to his perseverance and hard work. The main role of ChargeMOD is in the development of hardware for EV charging stations. ChargeMOD has established several charging stations across Kerala. This startup is only one of the few companies in India certified by ARRAY. Now we are over to Ramanunni. Ramanunni, you are welcome for this session.
Thanks, sir. Good afternoon, everyone. And I hope I'm audible in a way.
Yes, yes.
Yeah, thank you. So, like I said, I work with ChargeMOD. So ChargeMOD is pretty basically a small-scale startup, right? So we are basically into EV charging hardware, and EV charging ecosystem software. So what we do is very simple. We make the charging stations or the charging devices that power the electric vehicles, right? So first of all, I'd like to thank the College of Engineering, Talasheri, the faculty, and the entire team that runs behind this this specific program, for giving us an opportunity to present what we do, to present what we have done, and to have a little bit something say about what our company does. I mean, it's a great opportunity for us, and I'm thanking first of all for that. And thanking all of the audience, right? All of the eminent faculty from various institutions across India, and all the student members, and as well as the other audiences. Thank you for having the presence. Thank you for sparing your time so that I could present something to you. It's a big deal for me, frankly. So first of all, so that I think I should go to screen so that things could be a little bit more comprehensive.
You can go, Ramanunni. You can go with your slide presentation.
Got it.
That is the threshold number.
I hope the screen is visible.
Yes, Ramanunni. All the other participants are requested to mute your mic. Yes. Yes, you can continue, Ramanunni.
Got it. So, ChargeMOD, we are an energy services company. So what we do, like I said, we work with various aspects in the grid edge, like in the end point of the grid where things happen, or where energy is finally dissipated to the customers, to the end point, right? So we work in that segment. And what we do is very specifically in 2 segments, like renewables and EV charging. So environmental concern is primary, right?
Please hold a minute, Ramanunni. Just hold a minute.
Yes.
Please, all the participants are requested to mute your mic, as it's becoming a disturbance for our while presenting. Okay, fine. Ramanunni, actually, we cannot see you. Like, if you don't mind, it will be good.
I'm in a pretty low bandwidth area in my home, actually.
Okay, fine. Then this will be fine. Okay, Ramanunni, please continue.
Yeah. So, like I said, environmental concerns. Every person who is working in the EV sector or renewable sector, ChargeMOD and the personnel behind ChargeMOD, the workforce behind ChargeMOD is motivated by how the environment is changing, like how pollution is concerning the generations that are coming to us, and the current generation itself, and even our previous generation. They are taking a huge take on us, right? So what we can do about it? That's what the first thing that came to us. Like I said, it could be better if you could start a thing that could help do something about it, and ChargeMOD was a part of it, right? So that's how we are here. Like, the environmental concern, overusing fossil fuels are a big part of discussions among the global ecosystem, global political ecosystem as well, right? So I'll just straight away go into what we are here about and my specific session, right? The charging schemas and electric vehicles, right? So electric vehicles, in the very simplest definition, these are the vehicles that use electricity as the mode of supplyance of energy, right? Electricity as the fuel to continue their transport, or any transport mechanism that uses electricity to convert it into motion, right? It can be considered something that comes in under the electric mobility segment. And it's a pretty broad statement, and e-mobility is also a very broad schema, a very broad area in which there are multiple nodes that happens to come in India. Obviously the Paris agreements, the energy security concerns that India has, the recently India has been number one in generating solar or photovoltaic based systems, and most importantly, air quality. These are all concerns that is driving India into a wing of electric mobility. Plus, there is the most important concern of oil dependency, right? The huge country of India is having a very huge dependency on oil imports, which is a concern for each and every citizen, including, me, you, and everyone, right? So, like said, each and every one of us uses a vehicle or uses some kind of a transport mechanism that is based on the fossil fuel engagement system, right? So that's not good. That's not good for the economy. That's not good for the environment. That's not good for us, right? So that's why EVs are taking a lead. But truly, electric vehicles are not something that has come up right now. It has been pretty long that electric vehicles were introduced. Actually, in the 1800s, the first small-scale electric vehicles that was actually based on the VRL or the earlier battery chemistries, right? And in towards like the 1900s, we have the battery chemistries running to lead acids. The battery chemistries over these generations, the 1800s to 1900s, actually there was this period of electrical revolutions, electrical inventions, and even Edison in 1901 actually took on a scale, took on a method to have an electric vehicle being done, right? So, but from that period, from 1901 till a very specific period, right, 1901 to 1905, we had a run, but then it started to decline by 1920. There were multiple reasons to that. First thing, nobody was concerned about the oil prices, right? Oil was becoming cheap. Oil was being found everywhere. America was in multiple places finding out oil. Basically, that was the reason, right? Being America being the most user of vehicles, right? Vehicles in as a total, right? So America actually found oil in multiple places, and that's why actually electric vehicles came into a decline by 1920. Plus, nobody had a concern about pollution, right? Nobody was concerned about pollution. Nobody was careful enough so that someday in future this could be a catastrophic. This could lead to a catastrophic situation. Nobody was careful about that, even though there were scientists like Limeri who actually worked on these kind of situations. But it was not. It was kind of like a lone call, right? Nobody was concerned that much, like we are right now. But it didn't go that well in 1920s. But later on, there came a period of hybrids. Hybrids obviously are a combination of electric plus electric motor driven system plus gasoline or petrol or diesel driven system, IC engine system. Right. So that, 1997, 1990s, late 1990s over on, it took a time, and it actually came in for this revolution in hybrids. It's not a revolution. It was just a start in production of hybrids. And in 2006, a very specific company takes up their take on electric cars. And obviously, as I might know, you also might know the company Tesla. They were having a different vision. They were having a different ambition towards electric cars, and they wanted electric cars to be different. And during that time itself, there was another revolution that was coming up. The battery technology was being converted from lithium, the earlier lead acid type, to the lithium ion chemistry. And why that was possible was because of the inflation of use in mobile phones. These are related, right? So more use, you're going to use more mobile phones, you're going to have more lithium production, you're going to have more lithium mines, you're going to have more lithium in supply, right? Which means that in the end, lithium as a raw material is going to cost a little bit less because it's going in more demand, right? So that chain, actually, the more, because our generation and the generation previously before us started to use mobile phones, it led the battery technology that that drives the electric vehicles to be much cost effective. So that is something that is interconnected, and it's pretty interesting, right? So by 2006, even though Tesla was having this dream of having their specific electric car, they had their mission and they had their vision of having their own specific electric charging outlets as well, so that the customer's concern of having this electric vehicle ecosystem is cured. They don't have to worry about that. They don't have to have the anxiety of having the customers being put into jeopardy right? So these were the considerations that people had, right? So by 2010, we had the plug-in hybrid system, plug-in hybrid ecosystem that was developing. I'll come into the vehicle schema. And in 2010, you have the Nissan Leaf, which was kind of like one of the most sold electric vehicles in the globe. And that was also kind of like a difference in the electric vehicles in the vehicle schema that was coming up, right? So similarly, in 2013, the electric vehicle battery starts to decline from from this period, like 2005 to 2013, the battery prices was steadily declining, and the declining is still continuing, even though there has been a little bit bumps due to the pandemic and due to the other issues that came up in various lithium sourcing problems. But still, battery prices are almost 1/3 of what it was earlier, right? So that was the case before. And by 2014, customers were having choices. Like they could have a choice around electric vehicles, right? So the one of the most discomforting factor about electric vehicles when a customer tries to purchase an electric vehicle is that they don't get choices. They don't get choices. Like, see, if you're trying to buy an electric vehicle, you have like 3 or 4 limited versions, right? That should not be the case, right? Customers, whenever they're trying to purchase something, they should be given options. They have the right to options, right? So that is something that companies are trying to do. That is something that multiple entities are trying to do. Even though Tata, they are coming up 3 different models of electric vehicles in the same segment, right? So that's something that companies do, right? Customers need options. See, you have to have 3 variants. If you have only 1 variant, there obviously is a problem, right? So now, today, as you might know, electric vehicles are driving around the world, around India. Norway has got like 50% of electrification done, close to, and I think the sales of electric vehicles have been steadily increasing over a good pace, like 30 to 34, 35% year-over-year growth. That's a pretty good rate, considering the novice nature of the technology that people consider it to be, right? So now we come into a little bit more on the technical side, right? So what are the types of electric vehicles? So we have got 3 kind of electric vehicles. Basically, we have got 3 kind of EVs. One is a pure hybrid electric vehicle or hybrid electric vehicle. A hybrid electric vehicle, what it does have is a dual support. It has a IC engine or a petrol or a diesel engine, mostly petrol, plus an electric motor to support that IC engine. And it has a small battery to drive the motor, right? And basically it's an IC engine car with the motor support, right? So, and that battery could drive the vehicle on its own, maybe for like 20 or 30 kilometers, that's it, maybe 10, 20, 30 kilometers. But the purpose of it is to increase the overall fuel, to decrease overall fuel consumption, maybe increase the mileage of the vehicle in turn, right? That's what hybrid electric vehicle stands for. And the next one is plug-in hybrid electric vehicles. Very simple. It's almost a similar concept as hybrid electric vehicles, but generally they might have a little bit higher battery pack, bigger battery pack, and it could be plugged in from a outlet, right? They could be plugged in, and at the same time they might be having, and they should be having IC engines, right? So they are kind of like a hybrid, a true hybrid, right? It could be plugged in and it will be driven on petrol or gas or diesel as well, right? So that's the case with plug-in hybrid electric vehicles. And now we come into the third category, which is the battery electric vehicles, which when you hear the term EV, always consider battery electric vehicles. These two, they are called hybrids. They are never called EVs, right? Whenever you or me or hear the term EV, they refer to battery electric vehicles, right? So battery electric vehicles, very simple. You have an electric motor, you have a transmission associated to the electric motor, you have a battery that supplies power to the electric motor, and then you have a controlled environment that delivers the specific amount of power that the motor requires. It transmits, right? So that's how the battery electric vehicles work, and these are the different types of electric vehicles to be per se onwards, right? When you consider an electric car, like I said, an electric car and electric vehicle is always a battery electric vehicle, right? You have a battery bank, you have a onboard charger, you have a power converter, you have a electric motor and a motor drive, and you have a transmission, right? So very simple. The battery bank acts as the fuel storage or the energy storage system. The place where energy is curtailed for the specific purpose of driving the transmission, right? You have the onboard charger to convert the AC that you are receiving from the grid to the DC that is required to charge the battery bank. And you have a power converter, which is a DC-DC system that converts the output power to the required version that the motors and the other aspects that depend on the battery work. And now when we come into the motor section, you have the motor and the motor drive, which delivers the power to the transmission and which intakes the power from the power converter through the battery bank. Right. So when you come into the different motor types that are used, you have got the brushed DC, you have got the brushless DC types, you have got the induction motor that are used, you have got PMSMs or the permanent magnet synchronous motors that are used. Then you have got the SRs or the switch reluctance motor that are, it depends on manufacturer on which motor type that is being used. It is based on a different kind of assumption on which each vehicle chassis is built, each vehicle purpose is built, and the motor type and motor kind may differ, and it even depends on the battery, right? When you consider the power flow, like I mentioned on how an electric vehicle is designed, it's very simple. A battery, a converter, a motor director, a motor drive or a motor director, which is a pulse width modulating system, and a motor generator, right? So which is a system that delivers the power to the transmission and which in turn delivers the power to the wheels which drive the vehicle, right? It's a very decent, straightforward system when you consider the whole bus atmosphere, right? It's a very simple, straightforward system in which the the mechanical energy generating system is run by electrical power from the battery, and the battery stores the electrical power from the lines through the onboard charger. Right, that's the diagram or the diagram with the flow. Yeah, and when you come into the batteries, right now you have got two different kinds: the lead acids and the lithium ions. So lead acids are the earlier generation the types of the earlier generation battery type that was used. So like 10 years back, there were a bunch of electric scooters that came in with huge promises, right? So all these vehicles that came in was with BRLA or the lead acid batteries or the gel type batteries, as they call in the industry, right? So these batteries are actually built for their own purpose. They have high power. They can be designed to be at high power. They can be designed to be at high discharge rates. But the problem being, they always have a low energy density. They always have a low specific energy, and they always have a very poor temperature withstanding. And obviously, the cycle life was very poor. I mean, the charge discharge cycles that you could use on each battery, it was very low. These were the problems that led to the decline of lead acid batteries being used in electric vehicles, right? And then came in the generation of lithium batteries, lithium-based systems, lithium-ion batteries, right? So you have got multiple chemistries based on lithium. You have got chemistries that are not based on lithium that are still considered in the segment, right? So lithium batteries actually, they have a very specific nature that makes them usable for EVs. To be specific in nature, like they have a very high power to weight ratio and they have a very high energy density, right? And plus being the most efficient kind of battery that is available for commercial use as well. The energy density of lithium-ion battery is very high. I think 3.32 watt-hour per unit of assumption is as well available in the market right now, which is very high, right? So, but in order to achieve that kind of energy efficiency or energy density in lead acid battery, that was not possible, right? So these are the things that caused lithium-ion batteries to be used inside the EVs in the current generation segment, right? But there are multiple researches going on. There are multiple R&D processes that are going on to improve the current lithium-ion battery segment, as well as to finding out newer chemistries based on lithium or any other chemistry that could suit the energy storage requirement in the future, right? So now we come into the types of batteries. I've got some vehicles here. So this is the Tesla Model 3's battery placement. This is how it would look if you tear down the vehicle, right? So the capacity of the battery pack is close to 50 kWh. Total capacity. It has got close to 3,000 cells, 2,976 cells, which are divided into 96 modules in such a way that it gives a total output of 355 volts, I think. Yes, 355 volts. Yeah, 355 volts. So, and as you can see, the total capacity is close to 50 kWh, right? And each, as you can see, the total number of modules is 96, and each of those modules has got 31 cells. The arrangement of these cells is in such a way, like I said, is in generate to this very specific voltage, and is into generate that very specific current amperage output that is required for the motor as well as any other requirement. Now, if we take a look at another vehicle model, which is the latest in its segment, it is the Porsche Taycan, right? It has got a whopping 93.4 kWh of battery, but you might see that the number of cells and the number of modules are lower, right? So as you can see in Tesla Model 3, the number of cells are close to 3,000 and the number of modules are 96, but the capacity is pretty low. But when you come into the Porsche Taycan, the number of cells are lower, the number of modules are in turn lower, but the capacity is higher because the type of cell that is used in Porsche Taycan and Tesla Model 3 is completely different. The Tesla Model 3 uses an 18650 cell, whereas the Porsche Taycan completely uses a different kind of cell, which has got a better energy density and a better form factor in terms of design. So that's how they were able to achieve it. And the interesting factor about the whole battery setup, not the cell setup, the battery setup, that is it delivers a high voltage schema, like at 800 volts. So basically, the advantages of having a high voltage is that it will be obviously be on the lesser weight side, and the rate of charging and the rate of discharging could be on the higher side, could be manipulated to a higher segment, which means that your vehicle with an 800 volt capacity could be completely charged by a 350 kW system in about like 2 hours, which will give you in about 800 kilometers of mileage, close to. Right? This is today, right? This is not tomorrow. This is what we have today. A vehicle that has got 800 volt battery capacity and that can deliver close to an 800 kilometer range. And with a higher power battery charger, it can be charged in 10 to 20 minutes. That's the advantage that we are talking about, right? So this is what we have today. It's not something that is too far away. These are some vehicle models that are available in the market. Some of them are not available now, but as you can see, these are the different battery schema or battery arrangements that are being used, right? The Opel Almera is a basic bedside battery system or a flat bedside battery system. The batteries are cylindrical, type of LG chem. And if you can see the BMW i3, they use prismatic cells. They are different from the Opel Almera in terms of the type of cell used. And when you come into Chevrolet on the bottom right side, you can see the type of cell is used that they have used is pouch type. Right, it's a completely different schema. Right, so each of these manufacturers, they have got their own battery manufacturer arrangement. They have got some of them have got their own manufacturing, like the Teslas and some others. But when you consider that they have got their own arrangements on cell manufacturing, and each of the manufacturing chemistry, each of the chemistry on which the system is built or the battery is built could be different. Now we come into something called the BMS or the battery management system, which is the brain of an entire battery. So as you might know, the lithium batteries are a pretty sensitive device. They are very sensitive that they are labeled hazardous while in transit. So that's the level of hazard they could cause, right? So it's an issue. It's not something that's interesting, right? So the battery management system is an intelligent control system, intelligent electronic control system. Actually, it is something as you can see that is directly connected to the cells that is directly connected to the entire battery pack, so that the BMS can maintain the battery in a state such that the battery fulfills the functional requirements of the application that it was specifically meant to build, right? So if you need a very high specific discharge current during a very high specific time, the BMS is the guy who makes the test work, who makes the work test, right? So with the BMS, actually everything about the battery is controlled. The voltages, the currents, the state of charge of each cell, the state of health of the total battery and of the total cell type, the total cell distribution, the monitoring of each and every cell that comes in between the failure diagnosis, the error diagnosis, the voltage diagnosis, the balancing of each and every cell that is present within a battery pack. There are a bunch of tasks that an efficient battery management system could do. Plus, these systems could be smart enough that they have an inbuilt machine learning schema or an inbuilt AI schema that is running that could control the whole ecosystem very brilliantly, like in a kind of like an intelligent way, right? Now, a C rate is a term that is used by manufacturers, that are used by industry in research purposes, wherein it determines the discharging rate of the battery, and the charging and discharging characteristics of the battery they're not the same, like you might know, right? So a 1C battery actually means that the battery could be charged in an hour. A 2C battery means that the battery could be charged in half an hour. And similarly, a 0.5C battery means the battery needs 2 hours to charge, right? It's an industry specific term. It's a descriptive term to have, a basic understanding of the cell assembly or of the whole battery type, right? But it's a very frequently used term in the industry. I've got some vehicle models here with the specific battery types. The early vehicle models, the Mahindra E2 and the Hyundai Kona. The Hyundai Kona is pretty new, as you might know. See, the battery of these two vehicles, the earlier one, Mahindra, was a 72-volt version, and the battery of a Hyundai Kona is a 327-volt version. So that shows you the entire difference of how these vehicles were built with difference in time, right? So the Mahindra E2 Plus could actually be completely charged in about an hour with a 15 kW charger, which is the Bharat EVDC. I'll come into that. And the Hyundai Kona, it needs a power of close to 120 amps, like close to 40 kW to completely charge your vehicle schema. It takes time, like it takes similar time, but a different battery pack. That's the difference in electronic system or the charging paradigm that E2 and Kona has, right? So basically, the consideration is made in such a way that both of the vehicles are charging at 1C, right? So now we come into a different part of the whole schema, which is EV charging. Yes. So when we come into EV charging, we have got 3 charging methods, 3 charging schemas. The conductive charging schema, which is obviously the wired charging schema. You plug in the wire, the electrical wire transfers the electrical energy to the vehicle. Then you have got the inductive charging method, which is the wireless power transfer method. Similar, you can consider that in a very similar way to how you charge your mobile phone. You have got wired connectors, in which you connect the USB plug to the adapter and the other end to the vehicle. And the inductive charging is a wireless charging mechanism in which you place your vehicle on a wireless charging port. Indifferent to that, you would place your vehicle on a wireless charging parking slot. And the third way is the battery swapping, in which batteries are replaced as they are exploited, right? But it hasn't taken much a swing in battery swapping till now because of manufacturer disagreements. That's the case. But I'd say the most important way and the most prominent way of charging the vehicle is through conductive charging, or like said, normal wired connection charging, right? So, like said, if you're looking a little bit close on the conductive charging schema or the conductive electric vehicle charging method, you have got 2 schemas of charging or 2 methods of charging, which is one is AC charging schema and the other one is DC charging schema. Very simple. AC charging is when you deliver AC current from the outlet, and DC charging is when you deliver DC current from the outlet of the charging point, right? So when you're charging via AC current, as you might already know, battery can only be charged using DC. You cannot charge a battery using it. Battery always stores and charges using DC, right? So you have to convert the AC that is oncoming to DC anyway. So while you're plugging in AC charging, what happens is that the AC current goes through the onboard charger that is present in the vehicle, or the onboard converter that is present in the vehicle. It gets converted into DC of that specific voltage, and it gets stored in the lithium-ion battery. That's one way. That's the AC charging scheme. Second one is DC charging, in which the whole conversion aspect takes place outside the vehicle, right? So in this case, we bypass the onboard charger. We completely bypass the onboard charger. We communicate with the BMS directly, and in such a way that we could provide the lithium-ion battery with a higher power, at a higher power rating, at a higher voltage, and I mean at a higher amperage rating. I mean, the voltage is always same, right? The higher amperage rating, so that we could charge the vehicle, charge the battery in a faster way. If you're looking charging methods globally, you will find three methods: level 1, level 2, and level 3. Very simple. Level 1 and level 2, these two are AC charging schemas, and level 3 is DC charging. So level 1 and level 2, there is, there is a difference between level 1 and level 2, even though they both come in AC. That's dependent on the power delivered, on the power level that is delivered. So level 1 is anywhere, it's close to the home charging. It's close to delivering 15 amps at 230 volt. I'd say close to a maximum power of 3.3 kilowatt. That's level 1. And level 2 is it's in itself is an AC charging method, but it can provide more power. Like it can provide 32 amps at 240 volts on a single phase, and maybe up to 80 amps on a three-phase schema, right? So that is how level 1 and level 2 schema differs. And the difference is important because different cars could have different onboard converters. Some cars could have an onboard converter that has the capacity of converting at 15 amps or 3.3 kilowatts, while some cars can have a capacity of converting it within the vehicle at a higher capacity, like maybe at 7 kilowatts, which is 32 amps, right? So there is a difference in the AC power provided. So that's why we have two segments in AC, the level 1 and level 2. And now we come into level 3. Level 3 is very, like I said, it's the DC schema in which the AC-DC conversion happens outside the vehicle, happens at the charging station, and such a way that we could provide high voltage DC at high current to the battery to shorten the battery charging time, and in such a way that it could be completely charged in around from 20 to 80% in 30 minutes, right? So these things are not normally home used, while the level 1 and level 2 systems are home as well as commercially used. Level 3 is mostly seen on a commercial setup. Now we come into the protocol schema for electric vehicles. Protocols are some things, as you might know, that guides us to perfection, right? That guides us to that connection, right? So we've got different protocols that are available for EV charging. It's very simple, like what you have on your mobile phone, the C type, the USB-A type, the normal USB type. Like to that, we have got different types for charging your EVSE. It happened because earlier there was no coordination between manufacturers on which EVSE charging type to be used for higher, faster charging or a lower controlled charging. There were multiple questions between manufacturers, and nobody could come into an agreement during the earlier time. That's why we have this multiple protocols that are available in multiple regions. As you can see, in the North America, we have got the SAE's J1772 protocol for AC charging and the CCS schema for DC charging. Japan has got a ChargeMOD schema. ChargeMOD is a different type for charging. Like, it's a different plug. All you have to consider is that it's a different plug. It has got different connection arrangement. It has got different plug arrangements. And India, earlier, it had the Bharat EVDC, which is the GB battery, which is very similar to the GB battery in China, as you can see, for the DC. And in AC, we had the Bharat EVAC, or the standard 3-pin IEC 60309 connector for charging through AC in the earlier times, right? While Tesla always had their different aspect, their different take. They had their own connector, they had their own charging stations. Obviously, they are different and they have their own. Simple as that. But now, as you can see on the extreme far right corner, you're seeing a CCS2 schema, right? EU and the rest of the markets. This CCS is what we are seeing for the future, right? Because right now, every single manufacturer in India, mostly, and globally, are turning into CCS. Even Tesla had their vehicles coming adapted with CCS for the Asian market. So CCS, or CCS2 in its broad term, could be the way that we could be looking at a standardized protocol that is being used for charging the electric vehicles, CCS2. You don't have to remember about any of the others. All you have to do and remember is about the CCS2 schema, which is a combined charging schema 2, or the combined charging system 2. You can see a descriptive diagram of each of the chargers, which is the CCS1 on the left and the CCS2 on the right. All you have to do is look at the CCS2 on the right, which, like I said, is the common connector protocol that is being used by almost all electric vehicle manufacturers currently. So it is a combination charger, like it's a combined charging system. It combines the AC as well as the DC into a single port. In the top part, you have got the AC charging schema plus the control schema. And then the bottom part, you have the DC charging connectors, which are the DC plus and minus. Right. So the CCS charging schema, it can charge up to a maximum voltage of 350 volts at a varying voltage parameter from 200 to 1000 volts. Right, that which is a huge current. It can charge up to 400 amps actually, varying on depending on the voltage in which it is served. And now shadow mode, like I said, it's a different charging gun. It's a different charging protocol that was used earlier. Right? I don't think that we don't see any manufacturers using shadow mode right now. And the communication was actually CAN. As you might know, these different vehicles, they have an inbuilt internal communication that happens between the electric vehicle charging station and the electric vehicle before any charging session begins. In the CCS schema, you could see the communication was PLC, as in you could see. Here, the communication was PLC. The power line communication schema was used to communicate between the vehicle and the electric vehicle charging station. And in the figure, you could see the two pilot lines, the proximity pilot and the control pilot, which are the two definitive directive lines which leads to the connection and communication between the EV charger and the electric vehicle. When you come into shadow mode, it's a little bit more broad, it's a little bit more elaborated. You've got multiple connectors enabling multiple points. You have got a common connection that is based on CAN protocol, right? So this is what shadow mode's plug would look like in a simple diagrammatic representation. Now we come into GBBART, which is a different type of connector plug that was earlier in use, which was basically, it was in China. It was meant for various low voltage and high voltage vehicles that were manufactured in China. But and earlier, because we had much Chinese dependency on the vehicles that were manufactured in India, we were forced to use GBBART, but that's not the case now. I don't think many of the manufacturers are using GBBART now as a protocol. I don't think so. So that's why I'm not stressing more on it. But as you can see, it also uses a CAN protocol for communicating between the vehicle and the charging station. This is a broad representation of each and every protocol that is available. You can see the GBBART on the left side and CCS on the right side. Tesla, which has got a very specific proprietary connector, and the shadow mode on the right bottom side. Right. We'll send you the whole doc if required with the concerned person for a broader aspect on this if required. We'll come into some vehicle models that are available, in the market. Right. So the Mahindra E2 Plus was kind of like the earlier model that is available. Like it was one of the first generation models. Actually, the E2 Plus model, this is the model. This was actually developed by Reva. Reva, they were a startup based out of Bangalore, and it was run by one Mr. Chetan Maini sir. So Chetan sir actually devised a very cute vehicle called the Reva, and Mahindra acquired it. Later they called Mahindra Reva, and after it went to become called Mahindra Electric, and Mahindra Electric's version was E2. So this was the first electric vehicle, I would say, first commercially available broad spectrum electric vehicle in India, I'd say. But it wasn't much successful for electric vehicle, for a common person's car, it wasn't much successful. One, going the whole cost factor. Second thing was it wasn't secure as in from the very chassis design itself. And there were multiple models available actually in two battery voltage variants, 48 and 72 volt variants. And they had like very poor power output and very poor mileage, even though the ARI certified mileage could never be achieved. The normal road mileages would be almost close to half what the ARI certified mileages would be after maybe a specific period of time. That was the case. So it didn't take a much thing. And now you come into the Nissan Leaf. Nissan Leaf was actually, like I said, one of the earlier commercially accepted, globally successful electric vehicle model that was in the Chinese Indian market. I mean, the European market as well as the Japanese market, right? Not in the Indian market. It never came in the Indian market. So even though the Leaf was once introduced in the Indian market back in 2019, it wasn't commercially available. I don't think there are multiple vehicles available in India right now. It could be just a handful of vehicles. So they use actually the shadow charging schema, as you can see. So this is what shadow would look like in a vehicle on a Nissan Leaf, right? But like I said, it doesn't have the vehicle. I mean, the vehicle is no longer in much consideration anymore. Plus, Nissan's latest offering, the Nissan Ariya, actually comes with CCS, which is the latest charging connector paradigm, right? So that's the case. I think CCS is the way to go. And now you come to see the Nexon EV, which is the most sold electric vehicle in India right now. I think close to 7,000 or 8,000 vehicles had been sold over the past 1.5 years in the Nexon family for electric vehicles. And in Kerala, it's such a happy scene that the Nexon EV surpasses the sale of the Nexon diesel, which means that the customers are demanding more electric than more diesel. I mean, petrol is the first, obviously, but customers are having a consideration of electric over diesel, which is a good turn of prospects among the customers. And in the electric Nexon, you can see that the charging schema is CCS2. You could take a look at it. Yeah. Now, there were some other vehicle models that were earlier introduced. This was the first model of Tata Tigor EV, but the latest, I mean, the first model actually used the GB-Bharti connector, the Chinese GB-Bharti connector, which was present in the E2O. But later on, the latest Tata Tigor EV, which was launched like a few weeks back, actually uses the CCS connector. So CCS is kind of like the way to go. The latest Tigor EV, which is also based on the Ciptron technology that Tata Nexon is bringing in, so they also use the CCS charger. And Shadow 3 or Shaoji, it's actually a concept schema or a future concept design on charging, which is actually a universal harmonized way of charging every electric vehicle. That is something that is in consideration, that has been in consideration for quite a long period, I would say decades in long, but hasn't come to a fruitful something yet. But I hope, in future we might have something like that. But obviously, backward compatibility is something that every new design requires. If your new design is not backward compatible, then obviously it's going to backfire. So that's what they are trying to bring in. They are trying to bring in the backward compatibility of these vehicles on this design. It's the harmonization schema that was present in consideration during the 2020s. As you can see, the CCS schema is the singleton runner for a period up to 2035 to 2045. And by 2035 upon, we might see the Shaoji schema, which means that from this period to 2035, we will be seeing the CCS schema, which is a combined charging system schema for charging our electric vehicles, which could be seen as the common charging schema for charging every electric vehicle that are available in the market. But, as I said, DC charging could be very fast. You could charge your Tata Nexon EV in 40 minutes. You could charge your Hyundai Kona in 40 minutes. You could charge your MG ZS EV in 40 minutes and gives you a mileage of 300 kilometers. And it's a very good thing. But there are obviously bad sides of good things, like the battery degradation that manufacturers obviously proposed. A constant higher power charging, constant higher amperage charging could be something that is disturbing for the batteries. Could be, when they are charged at a higher amperage, obviously more heat is generated, more heat is transited, more heat is dissipated through each and every cell, which in a way is not healthier for the cell, right? And being, in a tropical country like India, being in a tropical place like Kerala, it could be a little bit concerning for the users in Kerala, because constant DC charging could add up to the heat that could be existingly present in the battery from the environment as well, right? So those are some limitations of DC. Plus, the cost of these systems, being charging systems, are pretty high, right? So these are some things that need to be taken into consideration for while having the picture of DC and AC charging in mind. These are the different AC plug connectors that are available in the Indian market. The first one is the IEC 60309, which are the normal connector that is used by the rickshaws, everything. The next one is the AC connector, the home connector that is used for the Nexons, the MGs, the Konas. And the third one is just a 3-pin normal plug connector, which the electric scooters, the electric autos, they use a normal 3-pin plug connector, which takes a 3-pin connector mechanism, the little South Africa connector, and they takes in the electricity at 15 amps. That's how it works, right? So maybe we could take a little bit of yes. So shall we take a small break of 5 minutes, sir?
Okay, sir.
Sure. Thank you.
Yes, Ramanunni.
Yes, sir.
Yes.
So shall we take a small break for 2 to 3 minutes?
Yeah, sure.
Sure. So that we could have a refreshment, small one.
Yeah, sure.
Thank you.
We can go for a 5 minutes break and we will resume at 3. Yes, we are receiving back after a short recess. I welcome Ramanunni to continue his session.
Thank you, sir. So we shall resume with what we have left, I think.
Yes, Ramanunni, your presentation is clearly visible.
Just give me a sec. Yeah. Okay. Yeah. These are some of the vehicle models that are available in Kerala right now and in India as in a whole right now. So if you're seeing these vehicles, almost all the mainstream vehicles are following CCS2. CCS2, which is a combined system, charging system 2. So like I said, these vehicles, these charging CCS2 schema could be what we are looking at. So from a research perspective, from a learning perspective, as in a point, we should be more focusing on CCS2 and the development of CCS2 over the period of time. So that how to make CCS2, which is a currently acceptable system, to a better way, to the most efficient way, so that we could ease the charging charging infrastructure problem, which is one of the most important criteria that define the growth of an electric vehicle ecosystem in any country. Like also, like in this is the CCS schema, and now if you consider the other schemas, there are some other vehicles like the Mahindra E2, the Tata Tigor, which was available before, right? It's not something that is available right now, but it was available, right? It's not available right now. These actually use the Chinese version, the Bharat EVDC or the GB Bharti, which I showed you earlier, the Mahindra E2 and the Tata Tigor. And the reason being was the whole schema was borrowed from various Chinese development agencies or various entities working in China, various manufacturers in China. And we actually tried to replicate the model in India, and obviously we miserably failed, because the problem was we miscalculated the identity of customers. We miscalculated that Indian customers would be happy with what Chinese customers were having. No, it won't work. Like it's not something that definitely works, right? Because the whole two-wheeler market in India, that's something that's very definitive of this criterion, this trend. The Chinese versions of multiple electric scooters that were available in India, in our most of the showrooms available near our towns, were not able to take up a win because of this very specific reason. Do not equate the customers of two different regions, right? So you don't get to equate Indian customers with the Chinese equivalent customers. The behavior is different, the environment is different, the financial reason that they buy a vehicle is different. In India, a vehicle is considered a second most important investment after you buy a home, right? So an investment that is that important is made after much thought, deliberations, is made after much thought, like much thinking, right? That is something that Indian manufacturers actually missed earlier on. But later on, like when startups like the Aether, like the Simple Energy, like Ola, they're having a new perspective on how scooters are designed, right? You might all be knowing about how Ola's 1 lakh plus booking. That's something that is pretty interesting, right? So plus Simple's close to 50,000 plus bookings right now. So that's something that's amazing, right? So it's because they were able to bring in a design philosophy, a philosophy in design and a philosophy in manufacturing that would be more appealing to Indian customers. That would be more appealing to customers who are looking into electric vehicles. Like I said, the choice of the purpose of having a choice. Right? Now, when you're considering an electric scooter, you have multiple choices. You have got Ola, you have got Simple, you have got Aether, you have got the TVS that is coming up, you have got the Bajaj that is coming up. You're seeing multiple options. Like I said, when you have options, when the customer has options, he is more prompted to give a choice between these options than go for the single model that is available. See, these vehicles, these models, these manufacturing companies, the startups, obviously they're going to have different models each and every following year. Like how you see a smartphone. Consider Samsung having one model and they're going to run with the whole model. Consider Apple's iPhone being the one model and that runs in for the whole lifetime of the device. That's not going to work out, right? You have to have the upgrades. You have to have the systems or the futuristic upgrades that the customers demand in time, and you have to add everything that the customers add in demand for every time. So that's the environment that Indian automakers or Indian startups who are working in the two-wheeler segment is working on, right? So that's a little bit about EVs and EV charging. Now we come into the most important aspect that is pertaining in the research sector, that is smart charging. So see, consider this scenario: 10 people, 10 people are buying an electric vehicle, 10 people, and they're having a daily demand of 7 kilowatt. And almost each of these people, almost every single one of these people are going to plug in their vehicles at the same time when they come back from office or when they come back from work, and they plug in for the night. That's how it's going to be. Consider the stress that this activity, this 10 vehicles alone could put on the distribution transformer. It's pretty huge. It's pretty disruptive. Now consider 10,000 vehicles in the place of 10 vehicles. Now consider 10 lakh vehicles, 1 million vehicles. Now consider a crore vehicles, crore electric vehicles that require charging demand, that are requiring constant charging demands, that are requiring differentiated charging demands. That is something that the grid needs to be working on, right? So right now, the grids, obviously, they around the world, it's not something that is pertaining to India. Around the world, they are not yet ready to take on the huge upstorm in electric vehicle revolution that is coming up, because it's going to be a click. People are going to buy in, and it's going to be a steady buy-in schema, a steady buy-in cycle. The grid is going to get affected. So there is actually a bubble, and that bubble is smart charging. And what smart charging does is that actually it buys in time for grid entities or the distribution companies in the grid edge for developing the grid edge to a better way, so that the whole infrastructure, when it get developed, the distribution companies or the power companies, they get the time, they get the efficient or the required time to upgrade the grid edge. That's what the smart charging bubble is about. It's not something that is pertaining to for something that is a solution. Smart charging is not a solution. Smart charging is something that is a controlled system to delay the catastrophes. I would say, in my perspective, I would say that's the purpose of smart charging. So basically, with smart charging on our take, this is ChargeMOD's take on smart charging, in which there is a distribution box, and from the distribution box, energy comes in through the power box, and from the power box, before it goes to EV charge, it goes through a specific electronic hardware, which we call this Smart Genie or the AmbiCharge system, which control and calculates the electric vehicle charging demand and the household or the specific demand that is existingly present, and calculates in such a way that the available load is divided among the most efficient way between the electric vehicle charging stations and between the existing load. So that's what actually our smart genie does, right? So you have got suppose you have got a total load of 30 kW. You can use the smart genie to get the flexible charging ecosystem, the flexible charging environment in which you charge during the lowest peak hours automatically, and make sure that you do not charge during the entire high peak hours. And you have got the smart energy consumption system method, in which you make sure that energy is consumed only during the minimum usage period. And you've got amperage adjustment schema that are built in, so the output values of the charging station that can be varied according to the demand requirements or the demand criterion that is being put up on the ecosystem or on the overall load parameter. Right. So that's how efficiently, that's how smartly the smart charging ecosystem plays the role. Right. It actually it should be able to interact between the grid, between the EV charging station, and between the household connection. Right. So that's how, if it's considered for a household residency, but if it's not, if it's considered in a commercial charging scale, then it should be able to directly interact with the grid, so that the grid parameters are directly communicated within each other, and this whole smart ecosystem is brought in. As you can see, consider you have a specific solar production, and as you might know, there are specific regions in which the whole solar production happens and the whole peak of usage happens, and there is obviously a derivative differentiation between the two usage schemas and the two availability schemas, right? So what we could do is schedule and make the charging available in such a way that this whole graph is widened. Like how you widen a graph, how you distribute the whole availability over the maximum of time period available, that is made through smart charging. Second thing is coordinated charging. Coordinated charging is in case in which you have a set of charging stations, like 10 or 20 charging stations, but you don't have enough power available to power all the charging stations equivalently. So what you do is distribute the power available in such a way that the power is distributed in the available load itself, so that you have 30 kW power, you have 10 charging stations. What happens is that each of the charging stations are defined to receive specific amperages. Maybe the first two should get 7 and the second one should get 3. It should get divided in such a way, or it should get divided equally. It's a consideration that is brought in based on how much charging station, how much power is available. And the next way is obviously peak management. Like I said, you have to consider the peaks, you have to consider the availability criterions with the grid, and then you have to adjust the charging cycles, the charging sessions or charging criterions in such a way that this coordination will bring in a benefit to the whole ecosystem, right? So that's what peak management is about. Now we come into the Open Charge Point Protocol. The Open Charge Point Protocol is a protocol that is defined by the Open Charge Alliance. The Open Charge Alliance is actually an open entity which works on bringing in a generic nature, a harmonic nature to the whole charging station communication. Now, earlier, before we discovered the charging pins and charging connectors, we spoke about how the electric vehicles and the electric vehicle chargers are connected to each other. We actually spoke about that. Now we are discussing about something that's a little bit more interesting, right? Like I said, on the research side, on the learning aspect, it's very interesting. OCPP. OCPP, like I said, it is the protocol that is defined to have this communication between the charging stations and the central communication system of the charge point operator. Suppose we have a charge point operator. A charge point operator is setting up the charging station. Charging stations are designed from birth to be autonomous. You don't have a manual person. You don't have some human personnel standing there collecting money. It's not in the way. It's out of the question. That's not something that is there. What we have is a centrally communicated autonomous network of systems that are simply connected to each other, simply talking to each other, talking to the central server, and the whole ecosystem is harmonically maintained. That is brought in through the Open Charge Point Protocol, right? The communication between EV chargers and the central cloud. So the OCPP actually gives the authorization to start charging, gives the authorization to modify any charging parameters of the charging station. The station in turn gives heartbeats, gives messages of the availability of the stations, the real-time statuses like the fault nature. Any fault is occurred in the station, that is also transmitted to the central server, so that these things are real-time monitored. And even reservation of a charging point is brought in possible through the latest version. And like I said, much of the aspect of smart charging has been brought in for OCPP 2.0, which is like 2.1.2 is the latest version, I think. So for 2.1.2, a broader version, a broader identification of smart charging is brought in the latest version of OCPP. So OCPP in its very sense is like a central communication schema, a central communication protocol that is independent of operators, that brings in interoperability, which is open, secure, and robust to communicate between any electric vehicle charging station and the central server system. Right, very simple. This is how the CMS would look like. A CMS is the front end of an OCPP server, right? How it would look for a person who is managing the systems. They don't have to see all the backend, right? They just need to see how to control, how to maintain. It's a front end. This is how the front end would look. You can have the control over all the charging stations. You can have the control over all the payment schemas. You can have all control over all the charging points that are individually available. You can know all the statistics, all the charging activity, everything through one single point, which is the CMS or the central management system. So that's about the OCPP and communication schema. Now we come into almost the final part of the session, which is the market analysis and trends that we are seeing in the electric vehicle market and the electric vehicle charging market. Earlier, I showed you a baton of the early developments in electric vehicles, how before it was. But this baton actually shows how the future has been put up by different companies on their vision on electric vehicles, different countries on their vision on electric vehicles, right? As you can see, France is to ban petrol vehicle sales by 2040. Scotland is saying that by 2032 we'll be phasing out complete usage. Norway actually has reached the goal by of 2025 by 2022. I think that's their thing. India, in a way, actually expects to go all electric by 2030, but it has been a little bit dull because of the pandemic issues. But I think by 2035 or sometime up, we should be having this complete electrification, or even before. Because like I said, it could be a revolution that's coming up. But many statistics suggest that 50% of electrification could happen in 2030 itself. So that's how the calculations go. By 2030, the lakhs and lakhs of vehicles that are running in India could be non-polluting, silent battery electric vehicles. And it could be a very happy and marvelous scene to be withheld, right? That's something that could be interesting. And if you're considering various companies, so for Volkswagen Group, they have considered 20 to 25% of production increase by 2025. And even BMW 2025 is the timeline. And I think for Volvo, they have put up a milestone of having the whole phasing out by 2025. That's good run, right? Even GM, Ford's latest vehicles, they're all electric, like the Ford, the Cadillac, the GM's Cadillac, the Ford's F-150 Lightning. It's completely electric. It's a monster. Like the F-150 Lightning it's a beast. It's something that is a beauty. And if you consider the Hummer from GM, the Hummer is electric now. Can you believe that the highest fuel guzzling vehicle in the world is electric now, the Hummer? So that's how we are seeing the environment that is growing, and it's an environment that is growing. And in 2020, this is the data that we actually collected from various sources. This was a sales trend that we saw in 2020. That was this is the collective calculation based on 2, 3, and 4-wheelers, right? This is not an individual segment, and I think 90% of the sales would represent 2-wheelers, right? So this was a scale of how vehicles were sold across India. And as you can see, this is a good number. The pandemic initiation period had a reduction in numbers, but it's good. And the numbers are climbing back to original. And I think by this, after 1 year, I think it has surpassed the wholesale. And I think it's like 18 to 20,000 EVs per month. This is the 2-wheeler representation chart on how the electric vehicle sales of 2-wheelers had been performing in the past cycle. As you can see, the Hero Electric, the generic Hero group that was separated from Hero. So they are the highest performing team for as well, since even within the last decade, if you consider Hero should be the player, they have been there for quite some time. They had a good name. They are having a good name. So that's something. And you can see Revolt, the Aether team and others are also coming up within the good scale, within the good range, right? So that's something that you should be looking in, right? So these are the sales chart that we have collected, that the data we accumulated from various sources, right? In Kerala, this is the case for the last September, till last September. Till now, I think it's close to 1,400 Nexon EVs. And Kerala is the highest buyer of electric vehicle Nexon EV. Kerala is the #1 state to have the highest number of electric vehicles. Kerala is the first state to cross 1,000 electric vehicles in terms of Nexon sales. Kerala is the gold mine for electric vehicle sales right now for many companies. So that is something that is there in Kerala. So we are having a good run. We are having a good environment growth. We are having the whole environment growth in charging stations also coming up. So now you consider a buyer who is going to buy an electric vehicle, who is planning to buy an electric vehicle. The #1 criterion is not price. From our survey, over maybe 2,000 or 3,000 people who were at multiple showrooms and who were at multiple dealerships and multiple, online display solutions. We collected the survey, and this is the culminated result. So the most important question is battery. How long would the battery last? How long would it take to charge? How long would it last? How costly would it be to replace? The thing is, uh, the customers should not be the truth is customers should not be worried about battery quality as much as they are worried about something else. But the truth is, I mean, the hard truth is they do. That's the case with customers. So obviously, demonstrating the quality of batteries, demonstrating the quality of vehicles that are coming up in the market is a must do for manufacturers who are planning to have a go in Kerala market. And in terms of price, as you might all know, electric vehicles are costly. They are costlier than their counterparts, I would say, because their cost had been steadily declining. And as you might already know, the cost of an electric vehicle, almost 30 to 40% could be the cost of a battery. So over a period of time, as the cost of batteries decrease, we could see a cost of reduction or in the cost of cost of electric vehicle. But when obviously you consider the cost of an electric vehicle, you should consider the total cost of ownership, and you can justify the use and purpose of an electric vehicle with the help of definition of total cost of ownership. Maybe over a period of 5 or 6 years, you can clearly justify how an electric vehicle performs much better financially than its gasoline counterpart. The next part in which a buyer is concerned is the vehicle range. Obviously, how much would the battery give? Kitna de diya hai? That's the primary question. Like the Hero's ad was that, right? So that is something that is very intriguing for the customers. The charging stations, charging availability, that's the number third criterion for customers regarding electric vehicles. And then obviously vehicle speed specs, those are other aspects. And there are like a multiple other aspects like the quality of body, the design, everything. But these are the primary aspects that a buyer would consider when they're planning to buy an electric vehicle. So there are multiple challenges faced in the electric vehicle market. Like I said, the customer mentality being the primary thing. As long as the market changes, as long as the customer starts to buy in, the market seems a little bit paced. But as I said, as we are seeing a growth of 34% YOY year over year from the last year, and I think it should grow to 287% as per multiple sources. So even though that couldn't, in percentage, that could be higher, but in terms of real-time numbers, it might not be that higher. So that's the case. So, but as in new markets come in, as in new market players come in, new companies starts to bridge in. Maruti Suzuki is trying to bridge in. Honda is trying to bring in. Almost everyone is trying to bring in an electric vehicle motor, electric vehicle design. And like I said, when customers have options, they would consider. That's the truth. Like the customers should be having options. The more the options, the merrier it is. That's the truth. So overall, the top speed characteristics is pretty high. You can reach since electric vehicles obviously they have a very high torque. Since they have no continuity connection, so they have a very high torque. Obviously, no moving parts that needs to transmit, burn out, have to take 4 strokes and then give a power. It doesn't happen, right? So obviously, it does give you more initial torque, right? So that's the case. The high top speeds are pretty much on par. It doesn't worry any of the normal customers. Range 300 is kind of like the nominal higher range, but more on the common side, I'd say it differentiates based on different electric vehicle model. So basically, the Tata Nexon could give you anywhere between 200 to 250 kilometers per charge, while the MG Isras EV gives you close to 300. And the Hyundai Kona 450 is for the higher battery version. In Kerala, we have the lower battery version, which gives close to 300 kilometers. So MG and Kona close to 300 kilometers, while Tata Nexon gives close to 200 and 250 kilometers. That's the real-time case. So as you might see in future, this could be the thing. We might have self-driving options that are electric. And the most important aspect of electric vehicles is not that it is something innovative. It is something that is innovative beyond scale, because many new technologies are based on electric vehicle platform only. The whole self-driving schema is made possible only because of electric vehicles. See, it's pretty difficult to have the whole ecosystem built up in IC engine system. It's very easy. It's very calibrated with while using an electric vehicle. So the whole electric vehicle ecosystem brings in an additional suite of technology development, brings in an additional suite of research options, like in the whole self-driving schema, like in the whole robotics schema, like in the whole battery schema, right? So this is something. See, batteries are something that are used in electric vehicles, but at the same time, batteries are something that are generic energy storage systems, right? So when we are having, like I said, when we started using mobile phones more, the cost of lithium-ion batteries went less, and we could use EVs. And when we start using EVs more, obviously we'll drive the cost of batteries much more. So that something that uses battery, like the energy storage systems that are costly, could become more feasible, like in the future, right? So it's all connected. It's all interconnected. It's all like a network of systems that need to be bring in for together. And that's almost it, close to my whole presentation. And I think if we have any questions or something, maybe I should take that.
Yes, participants, you can ask queries to Ramanunni. If anyone is having any queries, you can please ask.
Hello, good afternoon.
Good afternoon, sir. Please ask your query, sir.
Sir, myself Rakesh Salati. This question is regarding the safety during the means this CCS2 charging. During the charging, DC charging, what are the safety and precaution to be taken?
Got it, sir. Good afternoon. Good evening, Rakesh, sir. So I understand you have more on the question towards how we should be careful while charging the vehicle,
Yes,
right?
yes.
Yes, got it. So basically, the CCS2 has been designed with a very specific IEC pattern. I am not exactly remembering the code, but a very specific IEC pattern that requires to consider the whole safety parameter. Plus, each and every installation or each and every station installation has to be followed under the CEA guideline. There is a guideline from the CEA, there is a guideline from the Ministry of Power on how charging stations are to be distributed and deployed. So when you're considering the deployment, you have to consider within this. And obviously, like in Kerala, we have this electrical inspectorate inspection, and we have got various other aspects that we have to consider as well. So otherwise, from a personal perspective, it's just a plug and go method. The customer does not have to worry about any of the safety schemas. All you have to do is plug, charge, and go. From the customer's perspective, even if it's raining, it's completely fine. And that's how it's built.
Okay, okay. One more question is this is regarding when we go for means higher voltage charging method. So in that case, there will be means heating. So means fast charging. So what are the type of cooling in that case?
Yeah, sir, there are regulated cooling methods that are used inside the battery pack. So most cases, we'll be having the cooling based on how the ingress protection of the battery pack has been defined. So basically, if your battery pack is of a lower ingress protection, then you will be seeing a forced air cooling method that could be
Okay.
feasible, right? But if it's of a higher ingress protection, like on the IP6X scale, right, completely waterproof scale, then you should be looking at a water-based cooling system or a liquid-based cooling system, in which the whole cooling schema is different from battery to battery, and the final thermal management is made in with the help of BMS. The BMS actually connects to each and every cell, maintains the thermal voltages, and if there are any discrepancies in the voltages, in the temperatures that are coming up on the readings, then the BMS actually stops the operation or shuts the current activity. I haven't even had the queries coming up where actually cars went in shut because of BMS error, the overheating issue. It's completely controlled through BMS. Yeah.
Okay, sir. Thank you, sir.
Thank you, sir.
Any other queries? Dhirendra Singh sir, can you please give a feedback to our Ramanunni?
Hi, good afternoon, sir.
Good afternoon, Dhirendra Singh sir.
Yes, sir. So this session is very informative and interesting session, and lots of knowledge I got through Ramanunni sir, and um, very nicely and explanation is too good, sir. Nice. Thank you, sir. Thanks, sir.
Thank you, sir. Thank you.
Thank you very much, sir. Thank you.
Ramanunni, I would like to tell you one thing, that you have done an incredible presentation. But I still have a complaint that you haven't introduced your baby in detail with us. I don't know why. Hope we will come to know more about your brand in the coming session. We are looking forward to hear from you again on first session of our last day of the program, that's on 10th. On behalf of participants and College of Engineering Talasheri, I express my wholehearted thanks to you for being with us in this session. Thank you, Ramanunni.
I mean, the thanks is from my side. Like I said, it's an opportunity that I cherish actually.
Yeah, but why you haven't introduced more about your baby?
So ChargeMOD, it's something that we had been working about, the team, me,
Yeah.
Chris, Anup,
Yeah,
and Abhay.
ChargeMOD has installed numerous charging stations in different parts of the Kerala. So we want to know more about details regarding that. Hope you will say in much details regarding the same in the upcoming session.
Will do. Thank you, sir. Will do. Definitely.
Yeah. Okay, Ramanunni. See you on.
Thank you. Thank you all. Thank you for my patiently listening to whatever.
And one more thing, Ramanunni, all the participants are requesting for the slides. Are you ready to share it, or just video only?
I can share. Sure.
Okay, fine. Okay, you can send me through mail so that I can share it with them.
Sure. Thank you, everyone.
Thank
Thank you, sir.
Yes. Yes, participants. So with that, we are completing our today's session, and we will be returning back on tomorrow at same time. That is, our first session is on 9 o'clock, from 9 to 11. Then the second session is from 11:15 to 1, and the third session is from 2 to 4. For tomorrow, the two sessions are handled by Sajin Ismail. He is actually working as an assistant engineer in Kerala State Electricity Board, and the third session is being handled by Dr. Hemanthi Madam. She is actually working as a scientist in CSIR. So we are looking forward for a wonderful sessions tomorrow. So as for today, we are signing off. Thank you. Thank you for all your patience, and try to be present for all the sessions. Thank you.
Thank you, sir.
Thank you, sir.